All right, this is Craig Hartman. Thank you for dialing in. We appreciate it. We welcome you to this webinar. This webinar has to do with fuel in standby generators, which I think you'll find is much more interesting than it might sound. We also have a special guest that I'm pretty excited about, who we will introduce in a few minutes. Now, first of all, I'll mention that for those of you who may not do larger generators, gasoline is a fuel for a generator, but only for little generators that you might take camping or have in your garage. Because of its flammability and the fact that it doesn't store well, it's never used in generators of any size, either portable or fixed. So it leaves us with really three fuels. The one is diesel, one is natural gas, and the third is LP. Now, LP stands for liquefied petroleum, and it could be a number of mixes. In tropical places, it might very much be butane. In the North American market, because of the vaporization problem, we generally always use propane, and we will address that coming up. So let's take a look at the market share of the two fuels, gas and diesel. The mobile market pretty much dominated by diesel because it's a lot easier to carry a diesel tank around with you, a lot easier to find refills than to carry liquefied natural gas. In the stationary market, that's not the case. So let's take a look at the pie charts on the bottom. A 150 kilowatt diesel generator and a 150 kilowatt natural gas generator are basically the same price. As you get lower, then the natural gas generator becomes less expensive. So just looking at an equipment procurement situation, you are going to be better off buying a natural gas generator below 150 kilowatts when it comes to capital cost. Above 150 kilowatts, then the market favors diesel. So residential generators, basically they're all natural gas. I don't think you can even buy a residential generator that is not natural gas. And just to give you an example, you might be able to buy a residential generator that will sit permanently outside your house for a couple $1,000s. If you wanted to buy a diesel generator to do that, you're probably going to be between $20,000 and $30,000. So a huge difference. As you get larger, the size of the engine, it has to be larger to generate a single kilowatt of natural gas as compared with diesel. And so when you get up into very large generator sets, the cost of a natural gas generator is going to be approximately double the cost of a diesel. So that's reflected in our pie charts. You can see that about 2/3 of the market below 150 kilowatt is natural gas. And actually we're lumping in here natural gas and propane, but most of that is natural gas. As we get into the 175 to 500 kilowatt, you can see now diesel predominates, but you still have about 40% natural gas. And then when you go above 500 kilowatts, then you will see that over 75% currently is diesel. Now, this is a fascinating pie chart, I think, on the bottom. In 2013, if you look at all generators, 28% of them were natural gas and about 72% were diesel. If you look at that market share in 2016, that has changed dramatically. Now, 38% are natural gas and 62% diesel. You might ask, why is that? Well, the first obvious answer is the EPA. So as the EPA has come up with stronger and stronger standards for use of generators in general, it's harder for diesel to meet those standards. But there is another factor here that I think may not be so obvious, and that is the fact that in a natural disaster, natural gas is more reliable than diesel. So think about this. Diesel, you think, well, I've got it on site. We've got it on site, and therefore a diesel has to be more reliable than natural gas. But if you look at natural disaster areas, the diesels actually were less likely to provide power than the natural gas. Take Hurricane Katrina, for instance. The natural gas supply was always there, but there's floods. You couldn't get diesel. And even if you're trying to procure diesel when you have proper roads and so on, the diesel trucks, they don't have 1,000 diesel trucks just sitting around in case there's a natural disaster. They only have enough trucks to service their ongoing customer. So in a disaster, even if the roads are fine and the infrastructure is fine, your chances of getting diesel to refill your generator are pretty much nil, unless you happen to be a hospital or a 911 call center. Furthermore, natural gas generators simply are more reliable than diesel. So what we're finding is that the United States government is saying, no, we prefer natural gas for reasons of reliability, because you're more likely to have power in a natural disaster with natural gas than you are with diesel. The market share, that's 2016, and we're currently updating these slides so that we can get the 2019 numbers. I just don't have them right at the moment. Now, this is NFPA 110. There's three kinds of generators. There are generators that are emergency generators. Those result in the loss of human life, and NFPA 110 calls those level 1. Then there are generators that are less critical than human life, to human life, but still could cause a health issue or could hamper fire rescue or so on. Those are called legally required generators, and their NEC code 701 or NFPA 110 calls that level 2. Now, many people feel like if you have an emergency generator, and I should mention there's also optional standby. If you have an optional standby generator, you can do whatever you want. You don't have to even meet NFPA 110. But if you have a true emergency generator where it's critical to human life, don't you need on-site fuel? Well, here are the fuel options: diesel, LP, and natural gas. It says in the code for level 1 installations, now again, we're talking about emergency here, life safety, in locations where the probability of interruptions of off-site fuel supplies is high, on-site fuel storage of an alternate energy source sufficient to allow full output of the EPSS to be delivered for the class specified shall be required. So what does that mean? How reliable do you need to be to say that the probability of interruptions of off-site fuel supplies is high? Well, we're going to get into that in just a few minutes. It turns out that the person who decides that is the AHJ, the authority having jurisdiction, many times the fire marshal. So it is simply an opinion of the fire marshal whether off-site fuel supply, and in this case we're talking about natural gas, is high or not. And I'm going to get into some other things that will give you a little more guidance there. But before we do that, we're very, very fortunate today. We have Mike Favreau, who is the manager of regional operations for Dominion. And so I'm pretty excited to hear what he has to say, and he's going to talk about the reliability of the natural gas fuel supply. So I'm going to turn that over to him, and then after he's done, we're going to have a short question and answer session before we move on. Mike?
Thank you, Craig. Can you hear me?
Sounds good.
Okay, thank you. I'm happy to be on today, and thanks for the chance to talk a little bit about the product, obviously, that we sell, and being natural gas. And I'd like to talk about a few of the benefits that I see being a long-term natural gas sector employee, and then maybe a couple examples from our system of why I feel we do have reliable systems in the utility sector, utility infrastructure, and why it is reliable. And then I have a couple just things that touch on some actual earthquakes that we've seen around the world, and what happened with some of the natural gas systems in the ensuing days and weeks and months in those areas. So Dominion, if you're not familiar with Dominion Energy, we are in 17 states. We serve 7 million customers. We're a combo utility, so we have electric and natural gas service, as well as solar, and we produce a lot of other types of energy. In Utah, Wyoming, and Idaho, we serve 1.4 million customers. We're gas only here, so that's kind of a rundown of the company that I work for. Some of the benefits I see of natural gas generators, the first one, and Craig, you touched on some of these, so I'll be brief, but they're just very, very clean running compared to diesel. There's no exhaust smell. There's very, very little emissions. It's the cleanest burning fossil fuel that there is. And so that's one of the first benefits that I see. I think if you look ahead with diesel generators, if similar things follow that have followed with tractors and semi-trucks and even light-duty trucks. I drive a light-duty diesel, and I know since 2007 there have been very heavy regulations on diesels, as well as the need for diesel exhaust fluid in these vehicles as well. And I think that the day will come when not only will you store diesel with your generator, but probably diesel exhaust fluid as well that has a shelf life so that the generator can run clean. One very interesting point that's kind of a new thing with natural gas in the natural gas industry, we call it renewable natural gas. And so we're involved in several cases of this right now at Dominion Energy. One of them is one of the nation's largest pig farms. And so we gather the methane coming off of the pig waste, treat it, strip off some of the impurities, and then we are able to re-inject the gas, the methane that we've collected into our gas lines. And so usually natural gas is talked about as a non-renewable fuel, but in the coming years, you'll see it will become a renewable fuel. Maybe not to the scale that the drilling for natural gas is, but there are a number of different ways you can capture methane, which prevents the methane from escaping into the atmosphere. You burn it, and it's about 20 times less polluting if you burn it rather than let it escape. And so that's important, I know, to a lot of organizations and people right now on the renewable front. It is less expensive per gallon equivalent than diesel. You talked about some of the benefits of having it hard piped in. It's not going to run out. You know, you have an unlimited supply. We've had at our company, at some of our larger total energy facilities, we have some some diesel generators that are backup to us in the event that we have our natural gas generators down for maintenance. And we've had several different issues in our company with the diesel ones, from gelling fuel, even though we had additive in and they weren't able to start up. We lost our entire call center and operations center for about 4 hours a few years ago when we tried to switch to a diesel generator. And so there are some of those risks. Natural gas is safe. I know there's some people that are nervous about it out there in this discussion, not necessarily on the phone right now or on this webinar, but in this realm. You probably have natural gas at the facility you're running the generator with anyway, and so it doesn't add any risk to have a natural gas generator on top of your natural gas service. And it's relatively easy to get gas to these locations too, due to the infrastructure of utilities. And when I say I'm talking about the utility industry as a whole, not just the company that I work for. Another big risk that we see that's mitigated is no risk of having a diesel spill. You don't need secondary containment. We won't have any environmental issues on that front. And the last thing is it's usually very simple to hook up a natural gas generator if you already have gas near there or on site. And in the case of some of the very small ones, you can tie them into your existing meter. And in bigger ones, maybe you might need a higher load, but we're not talking production level gas load here. We're just talking the load to run an engine. So those are some of the benefits that I see. I want to talk now just briefly about why I feel natural gas systems are reliable. At Dominion West, we have 30,000 miles of pipe in the ground. We run that, as I spoke earlier, to 1 million endpoints. Feed comes into our system, and when I say feed, I mean high pressure feed coming from other pipelines and other systems, comes into our system along the Wasatch Front in Utah from several different sources, not just one or two, but all along the Wasatch Front. If we're to lose one or two or three of those sources, we can still function. So there's a lot of redundancy built in. We have, on top of our 30,000 miles of pipe, we have 1,000 miles of high pressure transmission pipe in our system that feeds and provides a lot of redundancy. This can be up to 1,000 PSI in pressure, so we move an enormously large amount of gas in up to a 24-inch pipe. We have isolation valves strategically placed all throughout our system so that if there's an issue in one spot, we can reroute gas or shut down that spot and isolate it from our system so we're not losing gas or pressure from any of our other parts. Very important to our residential system is what we call two-way feed. So we have very few services that don't have gas coming from two directions. So if there's a line break near your home or your business or your facility, we can isolate that and we can continue to bring gas in from the other direction, opposite of where the line break was. And this is very helpful to maintain service to our customers. Another item we use is varying pressures. We can vary our pressures that are in our pipes up and down. In our residential or intermediate high pressure system, it varies from 45 to 60 psi. But on our high pressure system, we can vary that by large degrees in the event of losing pressure in somewhere else in the system. We can ramp it up even if part of the incoming feed were to go away. Another thing that makes our systems, and again, when I say ours, it's utilities, it's not just the one here, is the increasing use of plastic or poly pipe. 85% of our system today of the 30,000 miles is plastic. Although steel is flexible and very strong, the new steel, not necessarily cast iron, but the new steel that's being used, plastic is far more flexible, and it's very difficult for it to be able to rupture just from flex. In fact, when we shut off, when we need to interrupt service, if we have a tear out, we can pinch the line completely off and stop flow. And when you unpinch it with a big hydraulic pincher, it resumes, it takes its shape back on and continues to flow gas. So the plastic that is being used today in natural gas infrastructure is pretty amazing. And we have that usually in delivery systems up to 8" in diameter in plastic. Another thing that utilities do, and it's of course not unique to ours, is we spend an immense amount of money annually maintaining and upgrading our system to ensure reliability, redundancy, and safety. Many utilities of our size will spend upwards of $100 million a year to make sure that our systems can handle what we need out of them. Of course, almost an entire natural gas system is underground, which at first thought you would think puts it to a lot of risk with an earthquake. And I'll talk about why we fare pretty well with earthquakes in a minute. But having almost no above ground infrastructure eliminates a lot of risk that above ground power and other things have that we simply don't have. And that's one of the biggest reasons that we don't have interruptions. I can think of a couple that affected very small areas of our system in the last 20 years that I'm aware of. They're very uncommon in the gas industry. And another thing that utilities are doing also is starting to build what they call LNG peaker facilities. So LNG is liquid natural gas. You chill natural gas to about 300 or 250 degrees below Fahrenheit, and the storage amount goes up by about 300 times when you turn natural gas into a liquid. And so companies are starting to put LNG peaker facilities in their system that could provide, it's a storage system essentially, and could provide gas for quite a while in the areas that they're near in the event of an interruption. Some of the recent examples that we've had where we've seen earthquakes and similar things happen, one of them is very close to home. It was in our system in Salt Lake City in March of 2020. We had a 5.7 magnitude earthquake, and apart from just a very few mobile homes that shifted on their block foundations and caused a little bit of problem with their flexible line that was on the customer side of the meter, we had no damage and no issues with our system at all. We did leak survey and a bunch of testing in the following days after the earthquake. Even when we spanned bridges with pipe and had areas such as that, we had no damage. And I'll talk about the shift that the earth can take and still not damage gas lines in a minute. The other thing that has been happening for decades is when pipe is bedded in the ground, companies have been very particular about what kind of material is being used that does protect the pipe, even if there is ground shift. Years and years ago, they would just backfill with native material, which was rocky and it wasn't very stable at a lot of times, and that could cause some issues. But for the past several decades, at least in our company, we've been bedding the pipe with engineered material that's very resilient. On July 5th, 2019, there was a 6.4 followed by a 7.1 quake in San Bernardino, California. There were areas where the ground shifted up to 18 inches and caused no damage to transmission pipelines. There were a few small leaks on private service lines. So by that, I mean residential homes that where there were probably leaks more inside their house when things had shifted than with the infrastructure itself. There was no damage to compressor stations, storage fields, or major pipelines. A lot of you will have present in your minds the earthquakes that happened in Christchurch, New Zealand. There's several studies that have been put out since then that have talked a lot about what kind of damage the infrastructure sustained. There was very little, although there was immense structural damage to buildings. We had a firsthand case in 1989. There was a large earthquake in California that many of you were aware of. And although there wasn't much damage to the system, we sent many employees from our company to go help relight customers because Good Samaritans ran around and shut people's meters off all day long that didn't need to be shut off. And so it caused quite a bit of problem. When we had the earthquake here in Salt Lake in March, the very first message we put out through the media, and it was about 5 minutes after the earthquake, we started getting a message out for people not to go turn off meters unless they could smell or hear natural gas because of the confidence we have in our system. Craig, that's about what I had prepared, is just some facts and some opinion matter on the subject that I had. And if you have anything to add, be happy to hear it, or we can take questions.
I think let's halt here for a moment, and any of our participants, if you'd like to type in a question, hopefully Mike will be able to take care of that. And Tyler, I don't know, you may need to help us out with probably reading the question.
Yeah, absolutely. Let me, we're going to have another question and answer at the end of this. So let me try and see any that might be applicable to Mike here. I do see one. Is there any possible problem of natural gas generators if they are piped or other natural gas equipment upstream may starve that generator?
So do you mean equipment upstream at the customer's facility?
The way they've worded it here is, I don't know if it's upstream at their own site or maybe at someone else's site, but it looks like they're asking if it's possible that natural gas generators could get starved for natural gas because of other demands.
I suppose it's possible. However, before a utility would run natural gas or run the necessary piping to hook one up, we would verify what the supply coming in is and then check that against the load the generator will have. I don't see this as any different as when we have any new buildings come online. We make sure we have plenty of capacity and that we size the meter and the piping accordingly.
Great. For right now, it looks like that was all the questions kind of related to this topic. I see some others about generators we might cover through the rest of the presentation. So we can just bring Mike back in at the end when we do our next question and answer if there are any other relevant ones.
Thank you.
We can go back to Craig to continue.
Okay, great. I'm going to continue talking a little bit about the generators themselves, and we'll plan on going about a little less than 20 minutes here, and then we'll stop. We'll end the presentation for questions. I'm going to talk. Let's see if I can. Tyler, I'm trying to get my, there it goes. Having a hard time getting to the next slide. There we go. Okay, Mike covered this much better than I can, but there have been several studies, one by MIT in 2013, the US Department of Energy, and so on. And all of them pretty much said what Mike said, but what Mike said was, I think he was so clear, I'm not going to bother going over those things. This is the natural gas infrastructure in the nation. The United States has a very, very robust infrastructure, which Mike has covered. Now, when it says, what is reliable? Well, the NEC does not have a definition of, and let me go back here. So just to remind you from where we were, it says, for level 1 installations where the probability of interruption of offsite fuel supplies is high. Well, is there a definition for what is high? What is the probability? Well, NEC does not provide a definition. NFPA 20, that's the fire pump standard, says that if you have had more than 4 hours outage in the previous year, then you would consider that unreliable. I know I tell the story, this is just me, of course, but I bought my house in 2003. That's been 17 years ago. And if the natural gas ever goes off, I'm going to have to relight my water heater. And I've never had to do that. So what is my experience with natural gas is 100%. Now, CMS is for nursing homes, and they said that to be deemed reliable, they need a letter of reliability from the natural gas utility technical person that includes the statements below that. So that was based on reliable for nursing homes. And of course, that's kind of a critical area. Now, the rest of this, I'm going to cover some of the high points. We have standby market is about 80% of all the diesel generators. If it's not standby, then we have several delineations of different types of generators. Some that run less than 500 hours a year, those would be utility interruptible and curtailable power programs. Those that run 1,000 or more could be used for peak shaving, and anything more than 4,000 generally we consider to be a prime power full-time application. We see a lot of those in combined heat and power, or what used to be called cogen. If you have a non-standby application, the EPA requires a lot of stuff, and Mike covered some of that. We generally would just say you've got to have an SCR. SCR is selective catalytic reduction. To add that to a diesel generator increases the price of that diesel generator by about 50%. So that's a huge adder. Now, natural gas, as I have indicated to you previously, in the very large sizes, is going to be about double the cost of diesel. So most people don't use natural gas simply because they don't want to spend the money. But when you get into something in which you need an SCR, we get a lot closer in terms of price. In-demand applications, there are a lot of places in the nation now where utilities are going to customers and saying, if you will buy a generator, or maybe the utility in some cases actually buys the generator, puts it on your property, and in the event that they have a power line problem and they need to curtail some load, they actually have the ability remotely to start your generator and transfer you to your generator so they can free up that power. And when they do that, then they will give you a break on your power bill. So this is a pretty great deal, and it's virtually all natural gas. And as you can see, the areas in the Rocky Mountain here in Utah, Wyoming, Colorado, we haven't seen that as much as many other areas of the nation, but I assure you, this is going to be coming at some point. So since this is not a demand response webinar, I'm just mentioning that, but we're not going to get into it in detail. Generally, there's limited run hours. The utility will say that we're not going to run your generator more than 300 to 500 hours, but our actual experience is less than 50 hours. I actually have a lot of experience with this because I was the director of engineering of Geneva Steel, and we had a 50 megawatt generator there in which we did this very thing, and the utility used us in whenever power was short in order to provide excess power. And I would say on average, I didn't see more than about 4 hours a year. So that's very typical. You get this standby generator, but it runs very limited time, and you get a pretty decent break on your electric bill. I'm not going to cover this too much, but that's more demand response. Let's talk a little bit about fuel. Diesel fuel has to be maintained to be reliable, and fuel maintenance must begin the day of installation. According to NFPA 110, you must do a fuel quality test every year on your generator. A lot of people are unaware of that. If you have a generator and you're not taking a fuel sample and sending it to a lab for testing, you are not in you're not in compliance with the local laws and regulations. That's NFPA 110. You must do that annually. And then you are likely to have to put in anti-gelling compounds, antibacterials, and so on. Diesel fuel doesn't just sit there. It's a maintainable item, and you have to maintain it constantly. And in some cases, you actually have to drain it and fill it with fresh fuel. Low sulfur diesel is a bigger problem. Why do we have low sulfur diesel? For emissions. But because we have the low sulfur diesel, the sulfur had a very strong ability to cause these microorganisms not to grow. And when we take that sulfur out, then the microorganisms start to grow, and we end up with these microorganisms generally between the water, and there's always some water in a diesel fuel tank on the bottom. And at that interface between the water and the diesel fuel, you get bacterial growth, and then that comes up and clogs the fuel filters. Another reason why diesel generators have problems if they're not maintained very meticulously. We also get higher wax content, and it's easier for the fuel to gel. You can read the rest of those. We wish we had the high diesel fuel or the high sulfur diesel back, but that's never going to happen. One thing we need to also recommend is that you do not use the biodiesel. Biodiesel has a very short shelf life, so if you're an over-the-road trucker or something, yeah, use it, it's great. But if you put biodiesel in your generator and it sits there for months, that biodiesel is very unstable and will break down and likely lead to clogging of the fuel filters in a generator that simply isn't going to start. So moisture, one of the problems. Biomass, we talked about, much more common with low sulfur diesel fuels. And gelling, things gel in the winter in cold atmospheres. It doesn't make any sense to try to heat the tank. That's crazy. I've seen a lot of people like to do that, but I've never seen one actually do it. And so we simply have to use a winter fuel blend and put in anti-gelling compounds to make sure that that diesel fuel doesn't gel at the lowest temperature, which you expect to see during the winter. Running out is another problem. If you have lots of diesel fuel, you have to maintain that diesel fuel. That drives up the cost. If you have little diesel fuel, then of course you're going to run out more quickly. If you have to have pumps and so on, you've got a day tank outside and you've got solenoid valves and transfer pumps and so on, then there's lots of things in there that add to the failure modes that you don't see when you just go to the natural gas utility. You hook up Dominion, that's all their problem to keep that gas there, and it just goes straight from their system to yours, excuse me. If you have these transfer systems and day tanks and so on in your system, lots of things there to fail. In the newer diesel engines, we use the common rail injection systems. You get very high injection pressures, like 30 to 40,000 pounds per square inch. And that means we have to have finer filters in order to make sure that we don't clog those injectors. When you have the finer filters, then that means you're more likely to have a clogged diesel fuel filter. Here we have the SCRs, which we've talked about, and we also have diesel particulate filters. The purpose of a diesel particulate filter is to take the tiny little carbon pieces and combust them in the diesel particulate filter, so you're not putting out soot, and that reduces the smoke and it reduces the particulate matter, the PM. And as you know, PM standards have gotten much more serious in recent years. What's the problem with the diesel particulate filter? The problem is it has to run for a while at a fairly high load in order to get hot enough to combust those little carbon particles. And with standby generators, typically that doesn't happen. They start up, they run for maybe 20 minutes at no load, and then they go down, and this particulate filter never gets hot enough. So you physically have to go in with your hands and clean out all of that soot periodically if you have a diesel particulate filter. These things all are used very commonly in prime power, but when you start using them on standby power, they really do cause a lot of problems. This is some of the sensors that are used for post-treatment, which drive up the cost. And I wanted you to look at this in the lower right. This is a particulate filter. And as you can see, that particulate filter just gets full of soot and doesn't work. If you had your diesel generator running at higher loads for long periods of time, that soot's all going to combust and that will stay clean. But you have to clean that out by hand if you have a standby generator. So all these things really are creating more and more problems for diesel. We have a customer in California that we're working with right now, and they're having a devil of a time. Even though it's a standby generator, California wants a complete selective catalytic reduction system on there, which drives the price up, as we say, 50% premium. And even then, they will come out and test periodically. And if you don't meet the new standards, then they will simply say you've got to replace the situation. And they're having to replace a diesel generator that's only 3 years old because the California emission standards have changed and it doesn't meet their new standards. And when they talk to the people, they're saying to their customer, you know what, we really don't want diesel engines in California anymore. We would prefer that you have natural gas. So we're seeing that a lot in California and other places along the East Coast. Now, for this particular customer, that's more difficult because the closest natural gas line is several miles away. And they, of course, you can get LNG storage technology, and they are actually looking at that a little bit. Let's talk about diesel versus natural gas. There are two different engines that go with diesel and natural gas. A natural gas generator has spark plugs, and a lot of the smaller natural gas generators start out life as automobile engines, and they modify them to use natural gas, which is a pretty easy thing to do. A diesel generator is a completely different engine. We call it a compression ignited engine. So those two engines are very different, and it's really two segments of the market. Here's your power strokes. The diesel engines are more power dense, and therefore a natural gas engine could be 30%, 50%, even 80% larger than a diesel engine because of that higher compression ratio on the diesel engines. And so you're going to find that a natural gas engine, the block is typically larger, number of liters is larger, and therefore as you get larger in kilowatts, that drives the cost up. Diesel engines are somewhat more efficient, however. Now, there are two kinds of diesel engines, rich burn and lean burn. Let's suffice it to say that if you run your diesel engine, or excuse me, your natural gas engine in prime mode and you're running it constantly, you're going to want to go with a lean burn engine. But rich burn is the way you want to go for a standby engine. Rich burns start much more quickly. Lean burn engine cannot start generally, maybe for 20, 30 seconds in some cases. I know we represent Generac. Generac says that all of their natural gas engines, and diesel too for that matter, we will guarantee that we can actually start two of them in parallel within 10 seconds. That's because we're using rich burn technology. And of course, rich burn means that you have more diesel fuel than air. Lean burn means you have more air than diesel fuel. But then we also use an air fuel ratio controller so that after they start, we then go to stoichiometric. In other words, there's not an excess of diesel fuel or an excess of air. We are simply running both of those in balance. Anything over 85 kilowatt, we use catalytic converters on our natural gas generators. And again, that reduces your NOx, your carbon dioxide, your carbon monoxide, and your hydrocarbon emissions. I'm going through some of these because we only got about 5 minutes left. So we'll go through some of these that are, I think, maybe less interesting. Lean burn is optimized for over 4,000 hours a year. If you're under 4,000 hours a year, you probably want to go with a rich burn engine. And these are some manufacturers. A lot of those manufacturers, actually, Generac makes the engines for them. Generac's the largest natural gas engine supplier out there. We're getting pretty close to the end. Gas piping requirements. We need to make sure that you have a gas pipe that can deliver the appropriate quantity of natural gas. We generally recommend that you have 10 feet or more between the step down regulator for natural gas and the generator, and that just gives you a little bit of natural gas storage in there to assist you in getting a reliable start. These are some of the piping requirements. Pretty much, I think what you would expect: protect the piping, have a shut-off valve so that you can shut it off if necessary, have diagrams, and so on. We recommend actually padlocking the natural gas valve in the open position, because our biggest problem with natural gas generators is somebody goes out there and turns off the valve. You can also use propane. Propane doesn't degrade. There is no maintenance on propane. You get a propane tank and it's there for life. And so propane works very well. The natural gas, of course, you don't have to pay for the tank and you don't have to pay to fill the tank. So I'd always go natural gas if I could. But if you're in an area where you really can't get the natural gas, or if the fire marshal, for instance, says, no, you have to have on-site fuel, you can go with propane. And we have generators that are dual fuel. What that means is you're on natural gas. If the natural gas supply fails, it will automatically switch to propane. And since the natural gas supply system is so reliable, in these systems, you just generally never, ever have to fill the propane tank. Now, one of the issues with propane is you have to vaporize. It's in the tank, and this would be with LNG as well. It's in the tank in a liquid state, and so you have to get that to vaporize in order to use it in the generator. And if it's an underground tank, no problem. If it's an above ground tank and it gets very, very cold, then you may have a problem with vaporization. And in that case, it's a pretty simple situation where we just pipe the liquid to the generator rather than the gas, and we put a vaporizer in the generator that vaporizes it there. Not a problem. You just have to realize that you have to do it. Total cost of ownership. Again, we mentioned that below 150 kilowatts, natural gas generator itself is cheaper. Above 150 kilowatts, it's more expensive. But if you look at it in the long run, the natural gas never runs out. It doesn't need any maintenance as diesel fuel does, and it is more reliable. So if you look at it in the long run, sometimes the natural gas ends up actually being the less expensive option. Install costs, we generally say about $150 per kilowatt. That's just a rough rule of thumb. And natural gas piping, if you have to run long distance, of course, would be an additional cost to that. Generac actually has a cost calculator. If you want to go in there on their website, you can enter things and it will tell you the ROI. I want to mention fuel cost, and we're just about done here. The cost of a BTU of natural gas is typically about 4 times less than the cost of a BTU for diesel. Now, that's probably not the case now when Russia and Saudi Arabia are dumping fuel on the market, but typically that's about right. Gas engines are less efficient. We generally say, just as a rule of thumb, that you can generate a kilowatt of power with natural gas for half the price that you can generate a kilowatt of energy, of electricity on diesel. So you actually are getting long-term savings every time you turn that generator on because you're paying less for the fuel. Load banking, you have to load bank a diesel every 2 to 3 years because they wet stack. They get carbon deposits in there. Natural gas doesn't wet stack. So we recommend you probably load bank 5 to 7 years just to make sure everything's in good shape. But that's another cost savings. Somebody bringing out a load bank and testing your generator, that's kind of an expensive item. In demand response, of course, you have the savings from the utility. So if we look here, this is our power ratings, and you can see in the long run, if you go through and you look at the life cycle owning costs, many times over the life cycle of the generator, even though the diesel is much more cost effective up front for larger generators, they end up not too different over the life cycle of the generator. If you're in a demand response application, then of course it's a no-brainer to go ahead and use natural gas. So I think we're about out of time, and I'd like to open it up for questions.
Great. I will help field those questions really quickly. I'll go ahead and bring Mike back in. There's a couple more questions that have to do with Dominion.
Okay.
Mike, your audio is back on. So the first question comes from Shane. It's, does Dominion identify essential facilities and provide priority service to these facilities? Examples include hospitals, sewer and water treatment plants, etc.
Yes, and that's probably a two-part answer. We do, and we have different rates for those. They're either interruptible or they're firm. If we were to have a supply issue, obviously the very first priority goes to the hospitals, the essential services. Now, there's a lot of questions that come up when you're talking about if you're installing an on-site generator that would be there as well. And we, I think we're probably the preliminary stages of some of that with large natural gas generators. But yes, we do establish priority and watch that very closely. Anytime we're at very cold conditions, and if we have any types of supply concerns, we watch that very closely.
Great. We got a question from Bob. This could be for either of you. Is there any practical way to store natural gas sourced from the utility line?
No.
Okay, great. Easy one. All right. The rest of these so far are looking like we do have one. This question is for Dominion. Do you have a contacting organization that we could call to get a history of outages to submit to authorities having jurisdiction?
Yes. Yep, we would have somebody in our engineering group that could have that. So if you need that, provide the contact that's asking the question to me offline.
Okay, absolutely. We will take care of that. Looks like the rest of these are probably going to be more on the generator side, so I'll take the audio back off mic and we'll have Craig work on these.
Maybe
we
have one from Cedric that talks about greenhouse gases. Is that something you want to comment on, Mike, or not?
I can try, sure. What's the question?
Does natural gas produce more greenhouse gases and does natural gas produce more greenhouse gases and non-renewable energy source? So I guess, how about greenhouse gases and natural gas?
So we've been taking a beating on that lately, just with all of the electrification talks that are going on. I can tell you that home heating produces a very, very small percentage of greenhouse gases out there. It's all from industrial. And so I don't know if I'm answering the question. Natural gas does not produce a lot of greenhouse gas. The greenhouse gas that I spoke of earlier that we're concerned about comes from methane. But if methane is burned, it's very much cleaner what comes off.
Yeah, now this is Craig again. That was half of the question. The other half was which has a longer lifespan, diesel or gas generators. And I would say with standby generators, we generally say generators rust out, they don't wear out. So if you're talking about standby generators, they can last 30, 35 years. And generally people replace them just because they're old and maybe they're having a difficult time getting spare parts. With prime power, they both last roughly the same amount of time. Now, natural gas is a little bit easier on the engines because it has lower pressures in there. But if you look at the lifespan of engines, even under prime power, you're going to see pretty much similar lifespans between diesel and natural gas. One of the things, I went on a cruise ship recently, Princess Cruises. I'm thankful I got off before the coronavirus hit. But they told us that the ship that we were on was the last diesel engine powered ship that they were ever going to build. They are converting all of their cruise lines now. Well, I shouldn't say converting, but all of their new ships are going to use LNG, liquefied natural gas, and they will use natural gas engines. So, that's a power application where longevity of the engine is very important. and they were telling us they expect to get better longevity out of the natural gas than they do the diesel.
Okay, great. Let's move on to the next question we've got here. I do see I don't need a tank to store natural gas when I use it on a life safety standby generator project, correct? I'm fed from the utility.
Okay, so again, this goes back to where we were on the beginning of our presentation. Natural gas is extremely reliable. And in most cases, when we go back several years and we say, well, how many outages have you had? What's the reliability? It's 100%. And so the only time you need on-site fuel is when you have off-site fuel supply, where the probability of interruption is high. So the answer is no, you don't need any natural gas storage on site. But you do need to talk to the fire marshal, and some of them probably need to be educated a little bit, because it's all dependent on the person. The person may say, oh no, I'd like to have on-site fuel storage. And if that's the case, then we have to have that. So we'd either go with diesel, or we'd go with a natural gas generator with a propane backup, which also gives you the on-site fuel. But in most cases, the answer is certainly not. You do not need any on-site storage.
Okay, great. The next question we have is from Bob. Are you seeing a combination of generators? I would picture natural gas as primary with a diesel backup.
We haven't seen that very much. I do have an application up near Heber where the guy is doing internet, he's doing television, he's got all kinds of stuff in there. And he looked at the natural gas and the advantages and disadvantages. And then he looked at the diesel and looked at the same thing and ended up buying one of each. So he has a diesel generator and a natural gas generator. But in general, we don't see that. I can't think of any other place where we see a combination of generators.
Okay, great. Next question is from James. Is the natural gas generator available in 13.8 kV?
Yeah, natural gas generators or diesel generators are available in 13.8 kV. Now, I'm not a fan of that. And I'm not saying it's not available. This is just my opinion. 13.8 kV, you got to have somebody that understands that voltage. The generator needs to be built, to provide safety at that voltage. And you're going to find that when you get just the difference in price between a generator with 13.8 kV alternator, now the engine's the same, but a 13.8 kV alternator versus a 480 volt alternator, you're going to add right there $100,000 to your price. So for me, I would much rather buy the 480 volt generator and then put in a transformer to step up to 13.8. And then all the service people, anybody can work on it because they're used to working on 480 volts. It's going to cost you a lot less. Transformers are extremely reliable. And a 13.8 kV alternator, if you have problems with that, of course, that's going to be much more difficult to repair than a 480 volt alternator. So the answer is yes, it's available. No, I wouldn't recommend it.
Okay, next question is from Brett. We work with customers that are in remote locations and don't have access to natural gas utilities. What are the extra cost implications for a natural gas generator system when the system doesn't already have access to a natural gas utility, and how does it affect the competitiveness with diesel generator systems?
Yeah, and of course, this depends upon the size. So if we're looking at a little generator, you could just put a propane tank out there and it doesn't cost you a whole lot. And the propane generator and the natural gas generator is really the same thing. We just change some of the orifices and so on for the mixing, because propane has about 2,500 BTU per cubic foot and natural gas is about 1,000. On the other hand, if you're looking at a big generator and you want to have a lot of power, or you want to generate a lot of hours, yeah, that becomes more of a problem. There are lots of natural gas storage systems, liquid natural gas storage systems. Now, you can't take power from the utility power. You can't go to Dominion and pull off their their natural gas and turn it into liquid unless you have a facility to do that. So you're going to have to truck that in as liquid natural gas. But there has been a lot of advances in recent years in LNG storage systems. I don't know, Mike, are you still on the line? Is that something that you feel like you could comment on?
Yeah, I'm still on. LNG is just tricky because you have to keep it so cold, and so I'm not aware. So when you speak of cruise ships, and we have some long haul trucking that's on LNG, the catch there is they use it up rather quickly. But if you need to store it and keep it in a liquefied state for an extended period of time, it's a problem.
So
Did
we
that
have.
answer the question?
What was that?
Did that answer the question?
I think they're just typing the questions. There are some great new systems for storing liquid natural gas that are recent, and maybe Tyler, we can get some information on that and send that out to everybody. In terms of what that does to the competitiveness, yeah, it makes it a lot harder. When you've got to have an LNG storage system, you're already double the price, and this is going to add significantly to the cost. And LNG, of course, is going to cost you a lot more to get than just tying into the Dominion system. But there certainly are people that do it, and so we'll try to send out information on that.
Great. Last few questions that have come in here. Looking to the future, is there more R&D in natural gas or diesel technology?
Yeah, so the answer is absolutely way more R&D in the natural gas, because a lot of places like natural gas, or excuse me, like California, are saying we don't want any more diesel. And I've talked to diesel engine manufacturers, and they're saying, boy, we've done about everything that it's possible to do to clean up this diesel fuel. We have these SCRs, we've got particulate filters. I think we're pretty much nearing the end of what we're available to do technologically. And with the US government saying, no, natural gas is also more reliable, that helps. And therefore, natural gas engines are really, there's a lot of research going on. And I know with Generac has probably 10 times more R&D money going into natural gas generators than they are diesel generators. Also, I would have to mention fracking. I mean, certainly fracking has helped us out a lot. We're looking now at not only the natural gas supply being reliable, but we're also looking at it being plentiful and being there in the long term. Maybe in terms of how long we can get natural gas and how plentiful it is that something you want to comment on, Mike?
Looks like Mike might have just dropped off. So
Okay, but you know, with the fracking, I mean, now they're looking, we got easily, and I haven't looked at this recently, but 100 years or whatever, we're plentiful with natural gas. Whereas diesel is not going to have that same. I think diesel is going to be around, certainly until my grandchildren are dead. But it definitely, without question, the market's moving to natural gas.
okay, last question we're going to take here. What are the price and labor differences between natural gas generators and the dual fuel generators?
Okay, there's a good question. So a dual fuel generator is almost free. It's not quite free, but all we do is we have a natural gas line coming into the generator. We've got a propane line coming into the generator, and we have a little solenoid. Well, it's a little device there with a spring. So when there's natural gas pressure available, it pushes this little piston over and it uses natural gas. If the natural gas pressure ever fails, that spring pushes it in the other direction and it uses propane. So if you want a dual fuel generator, and I'm just kind of guessing, maybe you pay on a smaller generator another $400. It's very small price wise. And labor is the same. Obviously, you have to run a natural gas pipe there and a propane pipe there, but that's it.
Great. All right. Thank you for all the questions and for participating today. We will be sending out information that Craig has promised, hopefully very shortly here. Otherwise, thank you for everyone for joining, and thanks, Craig, for your presentation.